Welcome, this is a Edexcel S1 June 2012 past paper. Now what I've done for you on the board here is just kind of put all the bits of information in terms of the equations that you're given in the formula sheet. However, you're not given these two, so what e to the x brackets ax plus b, and it gives you that, and the variance of ax plus b. Now what this means is the expected value, so instead of ex it's e ax plus b, so just kind of arranged it for you. As I said, that's a time for another video to explain that, but as I said, you don't get given that in the formula sheet, so I'm just recapping it now because we may have to possibly, certainly, definitely do this in the first question. And then the variance of ax plus b. But obviously, you know, we've only got it's a squared because the plus b doesn't affect the spread. That's essentially what the variance is. Anyway, I'll stop myself before I go into too much of it. But obviously, the expected value is adding a times each value and moving it across affects the expected value. Moving it up, whereas if you move this up, the spread is still the same. Anyway, I'll shut up, otherwise I'll probably explain all of it. And I'm assuming either you'll watch another video on that I'm going to do, or you are okay with that. Alright, so as I said, that's just a quick kind of recap on all the bits of information. Now, most of that, apart from the ones that I pointed out, as I said, are in the formula sheet. So what we're going to do now is get on to the actual main bit of the question. Sorry about that, I'm not happy with this focus, so I do apologise. So anyway, hopefully you've got that down. I'm going to move on to the actual paper now. So just rub that off. Right. Okay, so the first one, we need to draw a probability function, but we're given this information. Now, I'm assuming you've got the paper with you, but if you haven't, then I'm just going to give you the bits of information you need. So we're told that p is equal to x, x is equal to little x, and so the probability of, basically, what's the integration sign? The probability of when x is between, so minus, sorry, writing on the top of the word, minus 1, 0, 1 and 2, then the probability function, which is what this p equals xx, so it's a probability at each one of these. It is k brackets 1 take x, and that's squared. So that is for the first step, and then when k is equal to, and anything else that k is equal to, the probability is 0. Okay, so obviously we're just counting them between minus 1 and 2. Alright, because otherwise we've got no probability function, the probability is 0. So obviously it can't be anything else. Now we're asked to show that k is equal to a sixth. So the first thing I would do, we've got this and we're told the probability at each one of these is equal to this, and obviously it's going to come out with 3k, 1k or whatever it comes out with, or in one case 0k. But as I said, we're going to draw a probability function. Now the way you draw these, as I said, it's a quick sketch, so you're not going to get marks on it, but it does help you out and you do kind of need it really. So the first line is obviously the value of x. Now obviously the only ones we can consider between minus 1 and 2 included, because we said for anything else it's got a probability of 0, because it says otherwise if x is anything else it must be 0. So it's just between minus 1 and 2. So minus 1, 0, 1 and 2. And then probability of x equals little x. So the probability of each of these individual ones, we follow this, so we sub it in. So 1 take away minus 1, so 1 plus 1 squared, so it's 2 squared, it's 4k. Okay, then when we put 0 in there, it's 1 take 0 squared times k, which is just k. 1 take 1 squared, 0 times k, 0. So you just put 0k or 0. And then we sub 2 in there, so 1 take 2 squared, so it's 1 minus 1 squared, so it's just k. Alright? And then what I do at this stage, okay, so it's key at this point to not realise, oh, we've got the last value, probability of 2, we know that equals 1, so we just say k equals 1. But obviously that's not right, because we're told k equals 6. Now these are the individual probabilities for each of the outcome. Now, what we're going to write here is fx, and that's the cumulative probability. Now, we know the only probabilities can be between minus 1 and 2. So therefore, when we add up all these values of cumulative frequency, they have to equal 1. So if we do that, okay, So 4k first, 4k plus k, 5k, 5k plus nothing, 5k, 5k plus k, 6k. Now we know this number on the end has to equal 1. So if we do that, 6k is equal to 1, rearrange it so k is equal to the sixth, and that is as required. So you put a little thing to the examiner saying you can't get that wrong because I've got it right. Alright, so that's what you said, k is equal to 6. Now, what you could do in that situation is draw another probability table and write, where you see k, put a sixth. In other words, it'd be 4, instead of 4k, be 4 sixths, 0 would be a probability of a sixth, 1 would still be 0, and 2 would be a sixth. And then obviously the cumulative probability, if you wrote it underneath, 4 6, 5 over 6, 5 over 6, and 1 or 6 over 6. But you just leave it as k, it doesn't ask you to draw a probability function, but it's just nice to always have that there. And this is where it comes in handy. Okay, so the expected value, e of x. Now, I did give you the formula for, at the start, e(ax plus b. Obviously you need to know what e(x) is. Now, e(x) is something we call the expected value. And basically, what that means is it's the one you're going to see. You're most likely to see. Now, as I said, that's probably complicated. You can think of it as the mean, really, of these one. The mean being sort of, it's not the most common, but it's sort of almost the one in the middle if you think like that. But as I said, that's the median. But anyway, trying to give you a bit of information. I'm just getting some basic math wrong, so obviously just ignore what I'm saying. So essentially what you do when you have an ETX, friggin' hell. How much more I'm going to get? That's not statistics, that's C3. I don't know why you're listening to me, to be honest. So anyway, what you do is you times your x value by the corresponding probability. So that's why it's maybe not a good idea to draw this f of x thing. So basically you times -1 by 4, 6, add that to 0 times the sixth, add 0 times 1, and add that to 2 times the sixth. So if we do, I mean, even though we know these two functions, so 0 times 6 and 1 times 0 is going to be 0, we still write it in anyway, because I don't want to waste your life, obviously. So, -1 times 4, 6, 0 times the sixth, plus 1 times 0, plus 2 times a sixth. Okay, you work that out, obviously it's going to be -4, 6, plus 2 sixths, negative 2 over 6. And the expected value, the mean, we're going to expect it to be the closest to the side of the range with the highest probability. So basically it's going to be around about on the left hand side, which is obviously not going to be the positives, because in the positives we've only got well, technically include 0. It's going to be somewhere over here, because we've got the first two are 4, 6 and a 6, and by 0 we've already got 5 out of 6. The whole chance, so 6 over 6 is 1. We've got 5 over 6 chance of it being in the first two. So obviously we're expecting the expected value to be somewhere in between 0 and -1. And it is, so that works out. And if you've got an expected value for 2 or 3, obviously you know that was wrong. That's not possible unless you did some basic math error. Now, if, as I said, this is quite key, a good thing to explain. If you did x times f of x, and so -1 times 4, 6, 0 times 5, 6, 1 times 5, 6 plus 2 times 1, you would get an answer that's 3 point something. You should know that's wrong, because firstly, because we can't have an x value that's greater than 2, so we can't have an expected value that is greater than the range, because that's just not possible. And it's not closer to the left hand side, obviously. Okay, so just a little bit of a background there, and as I always say, just to get that bit longer revising, so just trying to kill you off, obviously, that's the reason why. Now this next part says ex squared, so it's not e bracket squared, it's e brackets x squared, squared is in brackets. Okay, so what this means, you just have to follow the formula. It's almost a polynomial. So what it's saying is e to the x, where each individual x value is squared. So you could write above this x squared, that'd be 1, 0, 1, 4. Okay? So it's basically the x value squared times the probability. Okay? So it'd be -1 squared, so that's 1 times 4 sixths. So basically 1 times 4 sixths, we're still writing a 0, even though, so you know it's not going to count for anything, 0 squared times a sixth, plus 1 squared times 0, plus 2 squared times a sixth, which obviously you know is 4 times a sixth, but right in. So 1 times 4 6, well that's obviously 4 6. These two we don't have a value for, so it's 4 6 plus 4 times the sixth, so it's 4 6 plus 4 6, well, I couldn't speak anymore, so it's 8 over 6, or 4 over 3 if you wanted to put that, or I'd keep it as a fraction. You could put 0.75, but seeing as we haven't put a number over here, I'd keep them both as a fraction, small. I mean, as I said, you can do that as accurate as you could get in a fraction anyway, but it's just nice to have a bit of consistency. Now this next part, you should have realised by this point we've got ex and ex squared. Now the formula for variance, so var of x, is ex squared, for God's sake, take, I don't know, one sec, let me just double check. Sorry, I thought I was going a bit crazy there. The variance of ex before. So the variance of, variance of x, sorry, is the x squared inside brackets, take e to the x, so the expected value, all squared, okay? And obviously, you should have realised by this point, that's a formula obviously, you get that in the formula book, but I was just being awkward. And it's trying to set you up, so it's trying to give you a hint, we've got to calculate the variance, because as with maths, they're not going to waste your time as much as they try, and I try and waste as much of your life as I possibly can, but you know, I don't have the power to stop you turning your computer off, but I probably will figure out that power someday. I'll probably get a price for it, but you know, just making it while I can. Anyway, so ignoring the diabolical future we've all got ahead of us, obviously, as I said, in maths, you will always have questions which lead you on. I can tell I've done a bit of law this morning, even though I don't. Anyway, different story in my life. Okay, so we should, as I said, in maths, you have a question which leads you on. So you could think, okay, what's it building up to? And if you get stuck on a certain part of the question, always look back and say, how can that part help me? I mean, obviously, don't look back at a totally different question, but just try and give you a bit of advice. Alright, so that's ex squared. Now D says find the variance, so it's one of them ax plus b things, so it's the variance of 1 take 3x. Okay, well, that's to find that. Now, if we put it in the other form that we had it before, where it was the var of ax plus b, and we said that is equal to a squared times the variance of x. Now, just because it's 1 take 3x, don't be worried that it's in the other way round. It's the a is whatever number is with the 3, so don't just assume because it's ax plus b and the x is over here that a is still 1, because remember a is with the x. Okay, so that might be a common mistake for people to make if they aren't properly paying attention to it, but you know, it's going to turn out to be positive anyway because we're going to square it. So it's a squared, so it's minus 3 squared, so it's 9 times the variance of x. So I just write 9 times the variance of x, and then somewhere over here, if you haven't already done it, therefore the variance of x, or var of x, is this formula over here. As I said, you're given that in the back of your formula book, but you're not given this bit. But as I said, you know, that's just for a different video. So its variance of x is ex squared, so you've already worked that out, so it's 4/3 take ex all squared, so it's take, no, it's not take away negative 2 over 6, you've got to square that first, so obviously it becomes positive 4 over 36. If I've got that right, just did that off the top of my head. Don't want to be wrong. I bet you I am though. Obviously that cancels down, that cancels down to 1/9, so it's 4 take a ninth. 4/3, sorry, take a ninth. And that gets you 11 over 9. Okay, that's the variance of x, so it's 9 times 11 over 9, which you don't need to calculate to work out, just 11. Okay, so that's question 1. I think it's quite a standard kind of question really. The only tricky bit was realising you had to draw the probability function, even though you didn't get any marks, which I think is actually quite a bit nasty in terms of not the actual question's hard, but just the fact you don't get any marks. But you can't really do it without the question. The only part I'd expect some of you not to be able to do is maybe this last little bit, but you could certainly find the variance of just x even if you didn't know what that meant, so you get a few marks doing it that way. Alright, so that was worth a nice 5, 6, 7, 10 marks. So if you couldn't do this, but you hopefully figured out you got the variance, worked out the variance of x, then because you got the formula at the back, you should at least get around 8ish marks on that, which is good. So you can afford to lose 1 or 2 marks over the whole paper, but I wouldn't aim to do it in the first question alone. So anyway, hopefully that made sense. I just learn the formulas for these that I showed you at the start. They're never going to ask you how does it come about. So you know, unless you intend to use it in a future career, then I would just accept that. But I will do a separate video on it for those of you that genuinely care or, you know, got too much time on your hands. So anyway, we'll see you in the next video. Thanks for watching.